Thank you for attending. Serena Bodner and my co-host Scott Payat is on his way. But right now, we don't have a forum or a format for monthly meetings. So it's kind of like whenever we come up with content, try to get something on the calendar. But I'm very interested in this in Tim's presentation because science and tech, especially in this area, is always just labs. I'm so tired of labs. I want to know what else is going on in science and tech right now. So when Tim volunteered to talk about a battery manufacturing facility, I was very excited about that. And I've seen the presentation and I think it's super interesting. So I hope you guys enjoy it. And we'll run through it. There'll be time for Q&A, I think. So yeah, that's what I got.
There'll be plenty of time for Q&A.
Yeah.
Yeah, interesting. All right. So I'm trying to figure out where I'm going to be looking, probably at the OWL.
Yeah.
There's only one person online, Jeannie.
Yeah.
Which is very interesting. Just to let everybody know, Jeannie is one of the founding partners of TRIA.
Yep.
She's no longer with the company, but so she can double check everything that I'm presenting here. She's probably created half of this content. So just as a kind of FYI, it's very interesting. But she's very generous with her knowledge and time. So, but enough about Jeannie. This is about me. And this project. So thank you, Serena, for inviting me. And Scott's going to show up. I've known Scott for many, many years. So again, my name is Tim Nisler. I'm an associate principal at TRIA Architects. And I'm going to be talking about a battery manufacturing facility design today. So I like to track things very kind of systematically. I'm a project manager by heart. So I put together an agenda. I'll give you a quick introduction of myself, an overview. Programming and planning is we're going to cover on here, design elements, project coordination. I think that all kind of goes in there. Timeline and milestones and a summary, quick summary at the end, and there'll be time for a Q&A. I think because of the attendance here, probably everybody can have 10 questions each. All right, so with my background, I'm a BSA member, AIA. I've been a licensed architect for the last 20 years. Crazy, time flies, right? So I have experience in multiple industries. I started my career in life science and higher education, but I've worked in healthcare and workplace, multifamily, residential. So the interesting thing about battery projects is that it's a kind of a combination of a lot of these things. I've worked for multiple multiple disciplinary firms. I've been an adjunct professor at Wentworth for 10 years. I've also mentored many young architects in NCARB, training young architects, that's important. Serena, I know, is an architect as well. And I manage projects of all sizes, from 500,000 square feet down to 5,000 square feet. All phases, full services, different, disciplines, landscape architects. So I've seen a lot in my career. So I'll just give you a quick overview of what I'm going to talk about. We're going to talk about the rules of kind of putting together battery projects, space types, the company goals when we work with clients, and also project goals. So the interesting thing, the first thing to know about working on battery projects is you don't talk about battery projects. The second rule is you don't talk about battery projects. They're very highly confidential projects, and they bring a lot of proprietary information to us. So what I'm going to be presenting here today, it's not going to be any photographs or plans of existing companies that I'm working with. It's going to be more of an overview to kind of give you the tools and an understanding of the industry. It's highly confidential. We sign NDAs. So if you're looking for a photograph of what's going on in the Mercedes plant, I don't have it. But I think you'll get a lot of kind of background and understanding and comfort level of how to approach projects. And that's the idea, right? So space types, it's really a combination of lab space, office space, and manufacturing, kind of the trifecta of those things coming together. We like to call it tough tech, where science meets engineering. But you need to know a little bit about all of those areas. But it's not enough just to know about one of those areas. It's how they all kind of come together is the key. Client goals, really, they're trying to create a project that has high energy density to it, right? So think about chip manufacturers. They want smaller chips, they want chips that are faster. And so it's the same thing with kind of battery companies. They want things to be smaller, more energy dense. That is kind of their goal, to kind of work towards the future. They're also sustainable companies. That's kind of the foundation of what they do, right? Sustainability is very important to them. So we bring that in the projects that we do. They want things to be recyclable, cost competitive, safe to use, long lifespan. The batteries right now have a limited lifespan, but they're always working towards that. And they want to be easy to manufacture. We don't want it to be too complicated. So that's what they bring as goals. They also bring speed to market, huge thing in batteries. They come up with their own technology, the way they do things. The quicker they can get it into the marketplace, sell it to others, or get there, the better. So that is kind of the underlying theme of everything: speed, 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 speed. A lot of the companies that we work with, they already have their technology figured out, and it's just a process of scaling up. They may have things that they started in a garage or a room or something like that. But we're going to help them scale up into a larger production facility. So that's kind of an overview of what I'll talk about. And again, I should have said Q&A. It'd be great if you held questions to the end. But then again, we have a smaller audience, so if there's something really kind of, picking at your brain, feel free to jump in and ask a quick question to clarify, so you don't have to wait till the end. Okay, so I'll talk about programming. Site selection is a big deal, components of the battery projects, and then workflow. And so I know working with our clients, really kind of thinking about their employees and how to get the best talent. It seems that they're looking for places within, the area of the city with public transportation, where the people actually live. People coming out of school, kind of young, fresh talent. So I think we've looked at areas outside of the 128 belt where you'd have to drive to, but they really got to focus in what's going on within cities. And so this is kind of a range. I think, anything within Austin, Brighton up to Somerville, maybe a little bit on the outer sides. That's really kind of the sweet spot.
I'm sorry.
Yeah.
Are you monitoring the waiting room?
Oh, it just popped up. I thought I was. There we go.
Okay. Yeah, thank you for that. It's a
Good
team
looking
effort.
out.
Yeah, nice. So then we also working with battery companies, we evaluate buildings that they could potentially go into. They're always looking in the market. I think right now, people understanding the Boston market, there's a lot of availability of space. There's a lot of availability of lab and office space that are the spec suites that are sitting there and right for the plucking right now. And so we help to evaluate an appropriate place for them to move into. So MEP upgrades, huge factor. It's not just the lab stuff that are already there, but they bring in other equipment. So expansion of what they need for manufacturing is important too. So we're looking at that. Loading docks are always a huge kind of element. We want to make sure that there's plenty of loading, and if there's multi-tenants in the building, that it's not just one loading dock, it's multiple loading docks coming. So you can see in this kind of project that we kind of looked at and evaluated, we have multiple bays for them to come in. Freight elevators. Freight elevators are also a huge thing. They're bringing in material, they're bringing out material, so the flow of not just chemicals, but it's the raw materials. That's important. And what I alluded to earlier, we're also looking at existing fit out space in buildings. So there may be a spec lab that's available, that's empty, has never been used. It's really helpful for speed to market. They can get into a space, get their people into that space, maybe modify an existing space really quickly. Again, that helps to get there. And maybe that component of the workplace that they need, they can start moving in and getting their ducks in a row. Amenities can be a big deal for them as well. Updated lobbies, meeting and gathering areas, so maybe things outside of their suites if they don't have them. Cafes, coffee areas. So a lot of offices, they offer some of those things, but can't be your specialized coffee or your mochaccino latte, double, whatever. And so that may be important. Locker room, bike storage. I was even digging around for amenities. I saw this thing in New York. I don't know if it's true or not, but slides in the lobby. who knows? You never know what the latest rage is. But I think a lot of building owners are looking for their competitive edge. So just kind of be on the lookout for those things. Okay, so when we talk about programming and planning, we want to talk about functional areas. A lot of times, clients are bringing a program to the table. We ask them to, if they already have a space that they're working in that may not be idealized, but to have some sense of what they need in a program is always helpful as a starting point. We can always develop that with them, but I think if they can kind of bring some idea to the table that we can refine with them is helpful. And setting up a process to gather information is important when you're working with these battery companies. It's rare that they just take all their knowledge and go, here you go, get started. As we kind of know, it comes in dribs and drabs. And so I think having a formal process to set things up, get information, get updated information as you go, it is very important. And the rigorous documentation. When things change, because we know things always change, to always have the latest and greatest information and update it so that you minimize mistakes and misunderstandings as you go through it. That's kind of the key that we found. So Jeannie will see some of these things that we offer at TRIA proprietary, but it's nothing really new under the sun. I think adjacency diagrams really important to have as part of your process. And I would highly recommend to stick to a process that you have. Tried and true, going from adjacencies to blocking diagrams to test fits to make sure that they have the appropriate space within their building that you're looking at is very important. And it gives you an opportunity for them to verify and go through and look and confirm as you're going through the entire process. I think especially when you have clients that are going into a new, maybe a brand new long-term lease, maybe they're in a 2-year lease now, and they go into a 10-year lease, understanding square footage requirements gets to be a little bit tricky. I mean, the idea of USF versus rentable square foot and gross square footage, they may not understand that, so they need help in really understanding the square footage. So being on the lookout for that. And again, we have kind of tool of the TRIA, proprietary for programming, tracking equipment. And again, it's part of this rigorous process that we use and that I think everybody needs to be using to be able to get through. All right, so let's talk about some of the components that you need to be familiar with. So again, a lot of this is about bringing raw materials in. We're talking about lithium, nickel, cobalt, graphite, metals for layering, plastic. It's all raw materials that need to get into the building, and we're not talking like a square, a 2 square foot box here. We're talking about pallets of materials that come in. So when they bring that stuff in, they have to have storage for that space, and then they mix and they coat. And so this is part of the process that kind of understanding. And I'm not going to pretend like I'm an expert in the knowledge of their proprietary way that they put things together, but these are some basic fundamental areas that battery manufacturers bring. They bring materials and then solvents, within the lab together into slurries. They apply it to metal, and it still kind of goes through a process. And so then they cut these, they dry them, and they cut them into segments that they can use, kind of compile together for assembly and formatting. So you have to have space for stacking, also aging products. So it's not things that are going to be there for a week. It's going to be there for months on end. So all of this stuff kind of comes into play. Testing the materials and areas for testing, and then finally distribution. So it's all kind of in one area. So there's a kind of a lot to understand with these processes. And again, depending upon what their end product is, there may be other proprietary things that they stick in there that they'll enlighten you on as you kind of walk through it. So along with those processes, there's equipment, large pieces of equipment that come into play. So these are some examples of large scale equipment for mixing and coating, slitting, making things together. These can be up to 10 feet tall, 12 feet tall. So they require lots of space and clearance around that. And depending upon the scale of your operation, it could be one piece of equipment or it could be multiple pieces in different lines. And so really understanding how these things come together is going to be important. These all have power requirements, ventilation requirements, and so it can get very complicated very quickly. Usually, there's a team of engineers that are working on this with the client, and they have a very innate understanding. Yeah. Okay, so maybe I can pause there and see if you have any questions. And keep going. I don't know if we have a timeline for everything since we started late. Are we still going to go?
We got 20, we got 20 more minutes. So I think we can,
Are we going to cut at 20 minutes?
what?
Are we going to cut off at 20 minutes or?
Do you, how long do
No,
you?
I have a lot more to go through.
Okay,
Yeah.
I do think that out of respect for everybody's time, we should probably try to keep it to about 20 minutes.
Sounds good.
Cut it and stop at 10.
All right, so I might whiz through a bunch of this stuff. But again, I think with the audience, I think you guys understand a lot of these components.
Mhm.
Yeah. Okay, so this is talking about space types with office, lab, and manufacturing, and those three things come together. So this is an example of, a potential building that has multiple tenants in it. So maybe two companies across a corridor from each other. I think when you're looking at these things, you're looking at, having components. Here's the first floor with an office component, a lab component, and then a manufacturing component. And one thing that building owners can do is that they can take out a floor so that you have this high bay condition. So it doesn't have to be a building that's designed specifically for manufacturing, but they can modify existing buildings. And so we've done that in a couple of our projects. So this is showing it open to the second level, a high bay of maybe 18 to 24 feet to give you that height. So there's lots of potential for that. So this is kind of showing an example of a workplace. So offices, I think we've all worked in offices. We understand those components, so I don't have to get into them, but they are in the office. So there's not a lot of people working remotely necessarily because can't, as a manufacturing company in the lab, you have to be in the lab. So that kind of correlates to people in office space. So, you're going to have a series of meeting rooms, enclosed offices, cafe, wellness, all the things that you would traditionally design for an office. Be important. Another thing that I want to kind of point out is we're showing glazing, and I'll talk more about this as we go through, but there's glimpses of looking into lab space from the office space. So this serves multiple purposes for the people that are working there, but also investors that may come through into office space. And as much as they want to be closed and private and confidential, once you get into this space, they want to be able to share and understand what's going on with the space. So that's a huge component. It's been a component in science technology. It's still a component in battery manufacturing. So, all right. Hey, Scott. Hi. So these are some images and examples of some of the spaces that are important to kind of look at and evaluate that maybe are not traditional. So looking at open collaboration areas where people can come get together and congregate, not just at workstations, also all hands cafes. So you have monthly meetings potentially, getting people together, and then huddle rooms. Huddle rooms, they can be traditional with, technology at the end of it, or they can have technology on the wall and really focus on, people that are there in the room and discussions there being supplemented by technology. So there's multiple ways to look at things. This also correlates to lab space. So you have your traditional open and closed labs, and this kind of represents lab space and kind of a generic lab. But they also come into, basic research labs that are chemical focused, fume hoods, and so all those traditional elements, but also battery development labs, which can be more mechanical and have process equipment, along with analytical labs with all the equipment that you would expect to have in those labs with electron microscopes, so highly sensitive materials, and also the support spaces that go along with them. PPE spaces, glass washing, anything that goes with labs, we can also apply to what's going on within the battery manufacturing. So these are some examples as well. I think collaboration is also a key when you're talking about these three spaces where you can have in-lab collaboration areas, but also the idea of science and manufacturing on display. And this is what I was talking about, those glazing areas that you would potentially have, viewpoints into labs. Nothing really new in the industry, but something that's really compelling and appropriate. It kind of correlates to the battery process. And then this is kind of the trifecta that we're talking about, getting into space types for manufacturing. And so really understanding the flow and the process, because it really is taking existing space, and spaces typically are not, automatically square or rectangular for you, and they don't have to be consecutive spaces that can be broken up, but it really starts along a linear track of understanding the sequence of these spaces with material storage, and then having your mixing and coding and assembly, along a track and a sequence. And then also a series of potentially clean rooms off to the side that they can use and clean and dirty transfer of these spaces. Being able to go back and forth in between them, and also testing facilities. And so they could be off to the side off of these linear pathways. Potentially cold rooms are part of this, and along with testing, they're looking at it for all environments, not just the ideal indoor environment, but testing outdoors. And again, talking about distribution and chemical storage. Chemical storage can be a big factor, whether it's chemical storage within the labs, but also maybe by a central chemical storage area that the landlord would provide by loading docks on the first floor. So these are all factors that we need to look at and be aware of. So this is some imagery of what's going on with manufacturing spaces, or potentially clean rooms. Oops, sorry about that. Again, this is not a battery manufacturer. This is just a kind of generic manufacturing. I'm looking at it, but with high bays and high ceilings. This also can illustrate that we're not looking at specific battery or manufacturing spaces that are built for that. They could also potentially be in wood buildings, a high bay would be construction, within the city. It doesn't have to be something that's created specifically for that. So there's all different kinds of situations. Buildings. Okay, so we talked about scaling up. So again, that's one of the factors that kind of go through all of this. You're scaling up the existing. They're starting from a small scale if they've already had done with their work. So we're helping them get to a bench scale or a pilot plant kind of a scale. So they may know their process at a small scale, but we're helping them potentially find a better way or retain that optimization, ease of use as they scale up. So that's part of the challenge and also the process. The things that we have to think about too are flexibility. So it may not be, looking at things just in a 2-year, but also 2-year, 5-year, 10-year, we're looking at long-term. Adding and updating equipment, 5 years in, we have to take that into consideration. If they have a line of equipment and a series of equipment in the middle of a space, how do you get that out of there, 5 years from now, or if something fails? So we really want to plan for that ahead of time to be able to address those situations. Or reconfiguring spaces. They may find that 2 years in, they may need more storage in space, or they may need different equipment. So you have to have flexibility to be able to look at things if they're rated enclosures and potential for that. So it's not just day one stuff, it's day 200, day 500. About that. Okay. So another thing when we discuss equipment, it sometimes gets lost in these things are people first design. So I think as designers, we really have a responsibility. Yes, we want to make sure the equipment fits, the equipment is appropriate for the situation, but it's people first design that really should take a priority. We really like to follow kind of well design, the ideas of those minimal things that are going to be important for people. Access to daylight, views, movement through space is very important. Focused, quiet space, so when people have the opportunity, again, when they're working in an environment, they still need a space to go off to for heads down. It's interesting working with a lot of these companies. They bring up ideas of, oh, hey, we have an IT group, and oh, we found a closet in the middle of space. We can just stick them in there because they don't really, need daylight. They like it to be dark and like time out. We're talking about people, and they need windows. They need, they need psychologically think, oh, I need the darkness to look at my screen of the people. And over the course of 8 to 10 hours working in a day, they need that. And so we tend to have to remind them, no, let's negotiate for sizes of windows. So that's really important to keep in mind. We also want to make sure when we're laying out spaces, the proximity to spaces that they need every day, so they're not having to go all the way across an office or a space to get there. Again, I said, it could be a space does not have to be contiguous. It could be on multiple floors, multiple areas. So proximity is important to think about. Organizing that space for major efficiency. And also, I think another factor that gets lost is safety. So understanding what's going on within the space you work in. I know this has come up with discussions on fire codes and rating labs versus workspace. It's the understanding the people that work there have the innate understanding of what's going on in the space that they're part of the company. People who are kind of dedicated, working in an office space like HR, they have no idea what's going on in the lab or the manufacturing plant. But as a responsibility, they need to understand things that take place there. And so I think being open and sharing information and providing them glimpses into that are important, as well as entrances and pathways. I think if you talk to these companies, because of security, they would love it if there was like one way in and one way out. But for people, it doesn't really work that way, right? And you need multiple ways, multiple flow. And so unless they're working for, the government, where it's a matter of national security, you need to have multiple entrances and ways to kind of flow. So we got to keep that in mind. All right, so I'm going to keep going. Coordination. I know that it's coordinating with consultants is important, but it's also coordinating with building owners and regulatory agencies. And so with the building owner, it's the infrastructure. So I know that a lot of our clients are owners. So we're able to kind of wear both hats and help them look at having the appropriate MEP capacities, not just for lab and office, but also the manufacturing, which can really ramp up. So being able to talk to them and coordinate with them. Again, advising them on freight elevators. So it's not just a matter that they have a freight elevator, it's location of freight elevators and access, so that they're not coming from the back corner of the building and having to go all the way through, other spaces to get to their space. So being able to kind of talk that through. Or future planning. So again, talking about what's going to happen in 5 years. So we want to be able to talk to a landlord owner on behalf, or in conjunction with our client, about the potential for expansion, what that would look like. We've had the good fortune of working with multiple tenants in one floor, stacked on top of each other. So coordinating with those multiple tenants and the landlord. I know that a lot in leases, you have the right to go up, you have the right to go down and penetrate spaces, but that's not always the best way. It doesn't really lend itself to relationships with your neighbor in the future. And so you really want to kind of take that into consideration. Yeah, you have a right to go through their boardroom with, ventilation, but is that the right thing to do? Maybe not.
We have about 5 more.
5 minutes.
I'm
Okay.
sorry.
I'll keep going through. Sorry, no problem. Consultants, we want to make sure that I call them the big three. We bring in code consulting, MEP consulting, structural engineers. That's always important. I don't think you can do these projects without them. But there's also the lifesavers that I call them the lifesavers. We like to bring in acoustical engineers as well. Sometimes they're required. Air and trainment consultants. process engineers to help kind of help to review and confirm productivity for the lines that kind of consultation with the owners, and also industrial. Again, another big thing is regulatory. So we don't always have these conversations with them, but I would highly recommend you do that with local inspectors to see if there's any specific things that may come up that are required for their city or the fire department. The fire department, we've understood it's getting more involved in these processes as, labs become more prevalent. Manufacturing companies to have early conversations with them. Also, mass DEP. So there's discharge, chemical discharge in some of these products that we work with. They're solvents, and so they may want to have an understanding before you get to the end for approvals to have them early during the design phase. Talk about also, code implications as we get to the 10th edition of the Mass Code. Okay, so with milestones, again, I would suggest following a tried and true phasing, going through all of the phases. Don't skip a phase. You can always shorten phases. Skip, but you don't want to skip from programming right to design development. Put a week in there for schematic design, just so you can have sign-off and a clear understanding of what the client is looking for. We know lead times are a huge issue since the pandemic. They still are. I don't think they're ever going to go away. So those can be project killers if the equipment's going to take a year to get, and you're planning on moving in within 9 months. So I think really kind of talking about that early. And occupancy target dates. Have that conversation early. When do they need to be in? Is it a hard date? Is it fixed? Or is there some flexibility? Can they use their existing space that they're in as kind of a soft move over? Or do they have to, is there a hard date that's part of the release? And again, do they have to restore their existing space into a white box, which may take time and focus. And back to the summary page, kind of wrapping everything up. We talked about programming and how site selection is really important, the design elements, the space types, project coordination is always important, and the timelines. And that's it. Ready for the Q&A. There was an accelerated version of
Thank you.
the presentation.
Questions? Anyone? Yeah. Feel free.
Thank you, Tim, for this very informative presentation and
Sure.
wrapped up in just 20-ish minutes.
Impressive, right?
So, and I'm very surprised. Actually, as a designer, you can release the flexibility of the building. And I always imagine this kind of manufacture should be like a warehouse building.
Yeah.
But it's my first time to be aware of the existing building to accommodate this. So my question coming to you is, you talk about a lot of factors to control. Is there a risk control factor play in the design? The risk, for example, you talk about a little bit about enclosure. Does the enclosure need to be ready for blast, huge fire? This kind of new things which may not be considered in the original design.
Of an existing building. Yeah. Well, I think the risk is really in the lab space. The manufacturing space, there's not a lot of risk. It's really at the level of a pilot plant that can, this kind of production for batteries that we work on can fit within a business use and not have any special requirements. It's not 3-hour rated walls, it's not 2-hour rated walls necessarily. Again, it depends specifically on the type of equipment that they bring in, but from our experience, it's really, it can fit within a business use building. And I was kind of surprised with that too when we got into it. It's like, are you going to have all, surround everything in concrete block? But that's not really the case. When we're talking about large manufacturing and you're bringing in different kind of proprietary materials, that could be a different situation altogether. But we're really talking about corrosives and materials kind of coming together and non-combustible. So
my question was very similar, very related. I didn't realize, so most of what your experience is within sort of pilot production plants. It's okay. So my experience has been with much larger plants, and that's where the rated assemblies, and not just rated assemblies, but rated assemblies in like 50 or 60-foot high spaces. You know, so how do you accomplish that? And that's a lot of, you know, kind of emerging technologies and interesting materials that allow you to do long span fire rated, you know, partitions and that kind of stuff. So like,
Right.
in your experience, like, because it caught my attention, you said wood frame buildings in urban areas. Well, you know, like, but on a small scale, that's much more manageable, right? So yeah, I guess we don't have too much to talk about there. A lot of my interest relates around, like, you know, when you talk about your adjacency diagrams and then your blocking diagrams and everything, like at what point does the fire rating and sort of partitioning come into play? But it seems like at the smaller pilot scale, it's less critical.
Yes.
Okay.
Yeah, definitely at this, the pilot scale, but we have worked on, you know, manufacturing buildings where it is highly separated.
Yeah.
You do have, you know, the 40-foot high ceilings that are long span, and it has been addressed, so you could easily go into a space like that. But that's kind of dedicated and built for that specific use.
Right.
I think our experience right now in Boston is, you know, those spaces are starting to come online and moving into that. But most of it is really kind of within the infrastructure within the city.
It seems like when you scale to a certain point, you're not even necessarily just separating different functions. You're separating like zones of the same function.
You're right. Yeah.
Yeah.
You have multiple lines, and you know.
Just back to your point about, like, if there was an issue, you know, you need to have isolation and containment, right?
Totally. Yeah. Yeah, I think that's the idea too, is, you know, what we're working on is not one big manufacturing space. It's a sequence of rooms. That, you know, if you need to rate them, or if there's some equipment in there that's a little more serious, you can easily kind of rate that and meters pass around. So they're rooms within rooms. But, you know, trying to get materials into them, so you have, you know, overhead doors that have to be rated, and potentially they get blast proof, things like that.
So the clients you're working with, are they intending to scale their operations, and you're trying to make them work, you know, so that they can be scaled? Or
Same location. Scaled. Yeah, I think scale, in a new location, not where they're at.
Yeah. Independent location potentially.
But there is a limit to where they can go. So it is kind of a pilot plant level.
Got it.
They're not going to be taking it over an entire building. That would take a huge modification. It
Sure.
would be more appropriate if they went into a building that was dedicated and designed specifically for that. This is kind of a mid step, but I think you're right. That's the next level. Hopefully they can get, you know, in 5 years, 10 years, have another conversation and go, okay, we can go into this space. So,
Sure.
as they kind of understand their craft too, I think they all have a unique approach to what they do that's going to set them apart in the market. So once they kind of understand that on a large scale, I think they'll be off.
I think there's a lot of different people that are going after the battery industry, right? Whether it's power tools or medical devices, but it seems like the car manufacturers are the ones who have, you know, scaled up to that enormous scale.
Yeah.
Like first, or one of the first.
Right. Yeah, we've had some interesting conversations about, hey, what's the goal? Is the goal to like get to a certain point and then sell it to GM? And, or is it to be more like, hey, we're a chip manufacturer, we want to sell it to everybody.
Sure.
You know, so that our battery is going to be in. I think that is the goal. If they have, you know, their battery is the best in the world, and can't duplicate it.
Yeah, so a lot of these places, they don't necessarily have, they're not producing a battery for whatever it is that they're making. They're producing a battery that's the beginning and end of the story for them. It's someone's going to use that battery, but it's not a battery that they need for some other product necessarily. Or do you have kind of both clients?
A little bit of both.
Yeah.
But they're on a need to know basis.
Yeah.
So some of that, you know, not sure, probably, maybe. I don't know. I'd like to find out. I'd like to come back and tell you more.
I'd love to have you back for a full 60 minutes.
Yeah.
So I'm gonna wrap this up. I'm sorry for cutting it off. But thank you very much,
Yeah,
Tim.
I appreciate it.
I think maybe we should plan a round two. Maybe we plan a round two, and maybe we talk about like manufacturing in general, which I think is of interest to people as well. So maybe we can figure something like that out. Just a thought, just spitballing here, but
definitely.
All right,
I think there was at one point we were gonna do a GMP program
yeah,
thing.
we were, yeah. All right. Thanks,
Well, I can throw
everybody.
it over to Jeannie to see if she has any questions.
No, this has been great. Thank you so much, Tim. I actually am not well versed in battery manufacturing, and so I learned some stuff today. And thank you to Serena and Scott for putting this together. I'm excited. This is my first S&T committee NOCO, so looking forward to the next one.
You have to come back.
Me too.
Yeah,
Oh,
Hey, can I put in a quick plug
Sure.
for, so I'm the chair of the Building Enclosure Council and other knowledge community here, and October 10th, we have our big event of the year, which is our Wagyu Symposium. Hopefully everybody can come, and I'd like to talk about doing some kind of collaborative events too at some point. You know, we've touched on that.
Yes.
yeah, I think there's a lot of overlap there.
Cool.
Great. All right, thank you.
Cool.
Appreciate
Thank
everybody.
you.
all right, take
Bye.
care.
Great, great.